Hi, IBSL2. We are starting our next unit, which is actually our last derivative unit, and we are going to be talking about the derivatives of natural log functions. So we're talking about y equals the natural log, so ln of x, and then we're also talking about exponential functions. In other words, y equals e to the x. We are going to do a lot in class as far as looking at why these rules occur the way they do. But we are, for the video tonight, I'm just going to show you guys the rules so you can kind of get them in your head. And then when you guys come to class tomorrow, you'll be doing an exploration of why they actually wind up being true. So go ahead and label your notes for natural logs and exponential function derivatives. We do have to remember the chain rule. So we do have to be thinking of the inside function and outside function. So the domain and then the range as well. So remember that with the chain rule, if we wanted to take the derivative of this function, we would have to wind up bringing the 7 down, so the derivative of the outside function first. So we pretend like 3x plus 2 is sort of like our variable at the moment. We're ignoring it while we take the derivative of the outside. So 7 comes down for the power rule. We drop our exponent to 6. But then we have to make sure we multiply by the derivative of the inside. Okay, so this is 3 in this case. If we gave this, though, a name, so let's say we gave the inside a name calling it g of x, because we spent a little time talking about composition of functions. And then when we actually take the derivative, we would wind up saying that this is actually 7 multiplied by g of x raised to the 6th power times g prime of x. We're going to do something similar with the exponential function and the logarithmic function, so I just wanted you to get the idea of we're considering these two separate functions, inside and outside, and we have the same for any function that we consider. Our first one, our first new rule, is when you guys have the function e to the x. It is not always going to just be x. It'll be e to the 2x plus 5 or e to the x squared. Whatever our exponent is, we're considering that our inside function. So when we take the derivative of e to the x is just e to the x, but then we have to take the derivative of the exponent, which we're calling dx. In this case, the derivative of x, okay, dx, derivative of x is just 1. So really we'd be saying e to the x times 1, or just e to the x. So if I have the derivative of e to the x, I wind up getting e to the x because the exponent derivative is just 1, which isn't going to change my answer. And we'll do a few examples where your exponent is not just x, so it will change the way your answer looks. The natural log of x, in this case, the x is inside the natural log. It is not natural log times x. It's the natural log with x as its domain. So x is inside this function. So when I take the derivative of the natural log of x, what that winds up looking like is the derivative of x, because remember x is my inside function, so it's the derivative of x divided by what the original inside function was, which in this case is just x. So again, the derivative of x in this case is just 1, and then I divide by the original inside function, which is just x. Anytime I take the derivative of a natural log function, I wind up having the derivative of the inside divided by the original inside. So if I wind up having, let's say I call this the natural log of g of x. Let's say it's not just x anymore. Let's say that inside function is represented by something other than just x. When I take the derivative of it, I'm going to wind up getting the derivative of the inside function, so g prime, and then divided by whatever the original inside function was, so just be g of x. And again, we're going to do a few examples with this. So far, when you take the derivative of e raised to a power, it is e raised to that power multiplied by the derivative of the power. For natural log, it is the derivative of whatever the inside, the domain was, and then divide by the original inside. Those are your two new rules for taking the derivative of our two new functions. So let's try a few examples together. This first one is your common chain rule, right? We just did one like this. So when you guys take the derivative, again, We're going to bring the 3 down, keep the inside the same, and my x's always wind up catching on this. Multiply by the exponent of 2, and then I'm going to multiply by the derivative of the inside, which is negative 2. So if I simplify, I wind up having negative 6 multiplied by negative 2, x, there we go, plus 1, and then squared. All right, for our new rule here, we have a natural log function. So when I take the derivative of a natural log, remember it's the derivative of the inside function, and then divided by the original inside function. So I can go ahead and put 4x as my denominator because that's my original inside function. The derivative of 4x is just 4. So 4 divided by 4x, I can simplify that down to 1 divided by x. Let's go ahead and try 2 more. This is an e. Again, it's not just e to the x this time, so let's see how this plays out. When I take the derivative of an exponential function, it is the exact same base e raised to the same inside function. Remember how up here with the chain rule, we don't touch this inside function the first time when we take the derivative of the outside. So e to the 2x minus 1 does not change. And this negative sign has to follow with us because it's our coefficient. But then I'm going to multiply by the derivative of the exponent, which is 2. So now if I simplify this, I'll have negative 2, and then e raised to the 2x minus 1. And that's it. Over here in number 4, I know that sometimes we like to go straight into looking at this e, but notice how e is being multiplied by x plus 4. That means that we have a product rule here. So I'm going to have to set up my product. So my u is going to be x plus 4, and derivative of u is 1. And then my v is going to be e raised to the negative 2x. And then my v prime is going to be my new derivative. So I'm going to keep e with the same domain. Remember, my inside function doesn't change. But then I multiply by the derivative of the exponent, which is negative 2. So I'm going to make that my coefficient. Now that I have this set up, in order to find y prime, I have to use my product rule. So u prime starts first, multiplied by v, so that's e to the negative 2x. And then I'm going to add to u, which is x plus 4, and then multiplied by negative 2, e raised to the negative 2x. This is set up correctly, but let's go ahead and simplify this a bit. If I bring, let's see, I've got e to the negative 2x. Let's go ahead and distribute the x plus 4. So that means I have negative 2x and then e to the negative 2x. That occurred when I distributed this x. So negative 2x e to the negative 2x. Now when I distribute the 4, I'm going to have negative 8 and then e raised to the negative 2x. At this point, I actually do have some common terms. E to the negative 2x and then negative 8e to the negative 2x. Let's see if I have some space. Yes, I do. Oh, good. So here I've got e to the negative 2x, negative 8e to the negative 2x. So positive 1e minus 8e, that gives me negative 7e to the negative 2x. And then I have a term all on its own, the negative 2x, and then e to the negative 2x. I can factor out e to the negative 2x, that's fine, but we can go ahead and simplify and leave it as is. And then last two, number 5 is a natural log function, but it's a little bit more complex than number 2 was. Looks very similar, but my inside function is 1 plus e to the x. So again, I'm just looking at the outside function. I'm looking at this natural log. I know that in order to take a natural log derivative, I need to take the derivative of the inside and then put it over the original inside function. So I'm going to go ahead and just write down 1 plus e to the x as my denominator. And then if I look at 1 plus e to the x, well, the derivative of 1 is 0. And then the derivative of e to the x is just e to the x. okay, since my exponent derivative is 1. And that's as far as I can go. That's it. So my derivative of the inside is e to the x, and then divided by the original inside function, which is 1 plus e to the x. That's as far as I've got. For number 6, this is again just back to your regular chain rule. Even though we're bringing in new derivatives, don't forget that numbers 1 and 6 are the types of problems that you guys have been doing forever, okay, since the beginning of the year. My personal philosophy on this one would probably be that I would want to rewrite it as x squared minus 3 to the negative 5th power. So before I even start, I'd want to rewrite this. So I'm going to go ahead and take y, and I'll write x squared minus 3. Raise that to the negative 5th power, since I'm going to bring it up to the numerator. And then that way when I take, I'm going to give myself some space. So I'll take the derivative over here. My negative 5 will come down. I've got x squared minus 3. And then drop 1 from the exponent, so negative 6. And then multiply by the derivative of the inside, which is 2x. I can simplify that. Again, my numerator is going to be this negative 5 multiplied by the 2x. So I have negative 10. Woo! Let's try that again. There we go. So I have negative 10x, and I'm going to go ahead and move the x squared minus 3 back down to the denominator. So now I have a positive 6 exponent. All right? So this is just kind of a smattering of a bunch of different derivatives that you guys are responsible for at the moment, because these are the ones that we've done so far. We are going to do more like this when we get to class next time, but we're going to stick to these 6 as a good starting point. So short notes tonight. Go back over and just make sure you remember the 2 rules for E and for natural log, and we'll see you tomorrow. Have a good night.